Hello friends, my name is Pranav Kansara and today I am going to talk to you about a very interesting machine learning solution from the Google Cloud platform known as BigQuery ML. Also in short I'll call it BQML henceforth. If you have been a SQL data analyst, and I started my career with SQL, SQL is to us like what ABC is for a kindergartner. And SQL is the first step most of us would have taken when it came to analyzing large amounts of data. Today, when you talk about machine learning, most of the machine learning happens through languages like R, Python, Scala, Spark, Julia, and so on. Python and R, of course, being the most popular. Now, what happens? How do you do machine learning if you do not know Python or TensorFlow or Scala, but you only know SQL? Today, as the machine learning world in terms of technology expands quite a bit, you've got so many AutoML tools which take away the so-called coding part from machine learning and allow you to create machine learning models at scale with very small amount of coding. BigQuery ML is Google's attempt to bring machine learning to SQL data analysts. So if you've been a SQL data analyst but you do not know an R or a Python, BigQuery ML is a blessing. What BigQuery ML does is it allows you to use the standard SQL commands and with a few added commands for creating your machine learning models, it allows you to create sophisticated machine learning models. It gives you multiple techniques, and I'll come to it later, using the standard SQL commands, and that is very good because then at least to create the very basic models, you do not need to know how do you code an ML model in Python, so either knowing a TensorFlow or a scikit-learn and things like that. One of the biggest advantages that BQML has on offer is most of the places when you on your Jupyter notebook environments, you create the machine learning models, you essentially bring the data from the data warehouse to your machine learning environment, or bring the data from text files, CSV files to your machine learning environment, bring the data from your big data platform to the machine learning environment. What BigQuery ML does is, rather than bringing the data to machine learning, it brings machine learning to the data. So right from within BigQuery data warehouse, like you would write your select star statement, it allows you to create machine learning models, evaluate machine learning models, and create predictions based on the models that you've just created. It is not a panacea for sure, that it doesn't cater to each and every machine learning technique that is out there. But if you look at the kind of machine learning techniques that are covered, so for example, if you talk about standard regression models, where let's say you're trying to predict the price of a house, or you're trying to predict the price of a car based on certain variables, that's your standard linear regression problem. It has got the linear regression technique aligned there. Similarly, if you are working on a quote-unquote classification problem, where you are trying to classify borrowers, whether they will default or not, whether you're trying to classify a customer will refinance or not, a customer will churn or not, right? Many different cases like that. For both regression and logistic regressions, both linear regression and the classification problems, it allows you to use regression techniques. It allows you to use boosted trees using XGBoost, which is a favorite for most of the data scientists. It allows you to use deep neural networks. More so, apart from the classification and regression problems, a lot of the times you also work on time series forecasting problems. So you're trying to forecast sales over time, you're trying to forecast the prices of oil, you're trying to forecast the gross domestic product of a country. Many time series forecasting problems are there. It allows you to create time series models using the ARIMA method. And ARIMA, again, if you're a data scientist, before the deep learning models took over, ARIMA was the most widely used and is still very well used method in time series forecasting. And finally, one more class of technique that is covered within BigQuery ML is the recommendation engine, or the matrix factorization matrix factorization techniques, which you use to create recommendation engine. So like you see in your Netflix, if you liked Avengers Age of Ultron, you would like Avengers Infinity War as well, right? So similarly, like the examples that you get on your LinkedIn, people you may know, many such examples in terms of recommendation. So to summarize, what BigQuery ML allows you to do is create all these models, and if you look at these techniques, it covers a vast majority. Things like random forest or support vector machine is not covered, but more or less a large chunk of the techniques is covered. One additional thing what it allows you to do is Google has got another method called AutoML. It's a separate module within Google Cloud Platform. And AutoML, really what it does is it evaluates multiple techniques and comes up with the best recommendation across different techniques, as well as within each modeling technique, tuning various hyperparameters. So with AutoML, you do not necessarily need to do that. AutoML will give you a recommendation on what technique, method gives you the best results and gives the best model. If you have sophisticated models created within TensorFlow environment, then you can even import your TensorFlow models within BigQuery and run the models from within BigQuery. So that's all in all the gamut of modeling techniques that are there. Few important points if you're trying to experiment. After looking at this, you decide to go to Google Cloud Console and try to create your own BigQuery, BigQML models. Is just keep in mind the free quota that's out there. So BigQuery allows 10 GB of storage at any given point of time, free of cost. BigQuery also allows you to process 1 terabyte of data per month without any cost again. But keep in mind, this 1 terabyte limit does not cover the create model statement, and we'll come to that. Create model is essentially the statement you use to create a new predictive model. So when it comes to create model, max amount of data that you are allowed to process is 10 GB again. Keep in mind, BigQuery is pricing based on not how much data is returned, but how much data is processed to return that data. So if you process a 10 GB data set, for example, to get 100 MB output, the processed data is 10 GB, and that is what counts against your quota. So we'll cover more in detail around how you create these models in BigQML, how do you evaluate those models, and how do you create the predictions across these different modeling techniques that I spoke about. So happy learning. So now, having understood what BigQuery machine learning actually is, let us get into more detail around how do you create a model in BigQuery, how do you evaluate the model that you have created, and then finally, based on the model that you have just created, how do you actually predict the values of the variables in question. First things first, let's look at how do you create a model in BigQuery machine learning. As I described earlier, BigQML is Google's way of introducing machine learning within your SQL commands. So the commands that I'm going to show you are going to, in a way, be coexisting with the typical SQL commands that you give for getting the data that you need. The first thing in the create model command or statement is obviously a way to tell BigQuery machine learning that you want to create a model, which you do by specifying the command create model. You can also, there's another variant of it where you say create model if not exists, means only if a model with similar name does not exist, then you create the model, otherwise it will give an error. Or you ask it to replace a model if a model with a similar name exists. So that is the first command that you specify. Next up is where you actually specify the name that you want to give to that model. So there are two parts to it. One, the dataset name where you want this model to be housed within BigQuery, and then followed by a period and the model name. This you can give any unique name that you want here. So that first part is basically specifying what model you want to create, whether you want to replace an existing model or just give you an error if a model with a similar name exists. The second part is where you provide a list of transformations. We'll come to that a little later, but typically when you work with large amounts of data in your machine learning models, you may want to create certain transformations, like for example you want to create buckets for numeric variables based on certain cutoffs or based on the quantiles information. That's just one example. You may want to create cross features between a pair of features. So we'll come to that later, but that's the second part where you specify what kind of transformations you want to apply to the data. The third part, very critical, is the options that you want to specify. And here options is where the core parameters of the model go. So for example, you tell BigQuery whether it's you want to run a logistic model, or whether you want to run a XGBoost model, or whether you want to run a neural network model. You also specify what is the variable or the feature name that you are trying to predict, and various other things like the L1, L2 regularization parameters and things like that. And then finally, the query statement, and this is where you get the data for your machine learning model. So it's a typical select star, select XYZ from ABC table, and obviously you can put in a lot of subqueries and complex joins here within that this query statement. But this becomes, the query statement becomes the part where you fetch all the data for your machine learning model. So now looking at it from top to bottom, from bottom to top, query statement is where you get the data. Then options is where you tell BigQuery ML what kind of model you want to create and various other parameters. Transform is where you actually tell BigQuery how do you want it to transform this data. And finally, based on all of that, it will create a model and it will store that model with this model name in a given data set. All right. So that is your create model command. Hope things are clear. Moving on, once the model is created, and if you don't understand it right now, just hang on. We will talk about it later with detailed example. Here I just want to specify the key syntaxes of the three main commands: creation, evaluation, and prediction. So now that you've created the model, you would want to evaluate the model. You would want to evaluate the various measures of accuracy, the predictive power of your model, and that is where the evaluate model command comes in play. All right, and the way you want to specify that is select star from, and then you say ml.evaluate. So this tells BigQuery that you are trying to evaluate a model that is already created. So ml.evaluate becomes your primary command. Select star from just gives you all the output that is obtained from that ml.evaluate. And then here within ml.evaluate, you specify which model you want to evaluate. So if you look back here, you had this data set name and the model name. That is what you specify here, any model that you want. So model, data set name, and the model name. And then you specify the query statement. This query statement is the one that gets you the data. You have to make sure that your query statement is getting you the same data that you have used in creating the model when you go to evaluate. The names of the features have to be the same. They cannot be different. All right. And then the third thing that you can also specify is a threshold. All right. So for predicting good or bad, you can also specify a threshold that it should use when predicting good or bad, and then do the evaluation. All right. Second thing, when you're talking about evaluation metrics, is evaluating a model is the confusion matrix, and the command for getting the confusion matrix also is pretty similar. So you do a select star from, and then you say ml.confusion underscore matrix, and then the same thing, you specify which model you want to obtain the confusion matrix for, and what is your query statement to get the actual data, and what is your threshold. All right. So that's about evaluating the model. And then finally, how do you get the prediction from the model that you have already created? And that is where the predict model commands come in play. Just keep in mind there are 3 different sets of commands depending on which model you're trying to predict values from. So for regression, and we'll first cover the regression and the classification models, where again you do select star from, and then the key command that you use here is ml.predict. All right. So ml.predict, and then again you specify which model you're trying to predict from, the query statement, which actually gives you the data set on which the prediction should be run. And then finally, again, you can specify the threshold. So if you look at this, these two very similar to each other, just the ml.evaluate gets replaced by ml.predict. The constituents are the same. You're specifying the model, you're specifying the data, and you're specifying the model, the data, and the threshold. Again, keep in mind here that the names of the variables or the features that you're trying to predict should be and must be the same as what you had used in the query statement here. Okay, if they are different, you'll get an error. So that's for the regression and classification problems. The second class of models is the time series models. Again, where it's a little different. So what you're doing is, instead of ml.predict, you're using ml.forecast for time series models. Again, you're giving the model name. You're giving 2 different parameters here. Here you are giving the threshold. In this case, you are giving what is the forecast horizon. So you're giving that as a number. And also you're giving the confidence level, at what level of confidence you want the model to predict the time series values. So essentially, there is no query statement here, because it has got the time series data in the model itself, and all it will do is, based on that data, it will give you the prediction for the forecasted horizon. And then finally, if you have a matrix factorization kind of model for the recommendation engine, it's a little different again, where here you're doing select star from, instead of ml.forecast, you're doing ml.recommend. So 3 commands for predictions: ml.predict, ml.forecast, and ml.recommend. Predict is for regression and classification, forecast is for time series, and recommend is for matrix factorization. Again, ml.recommend, you're specifying the model and you're specifying the query statement. Please note that unlike the predict and the forecast functions, there is no optional parameters around either the threshold or the horizon or the confidence level. It is just the model name and your data set or the query statement. All right, so this is a quick overview of what different functions within BigQuery ML look like for creating the model, for evaluating the model, and finally for predicting the values. In the next section, we will look at the model creation part, which is this one, in more detail, and we will look at an example of how do you use this to create a model. Stay tuned. So in the previous section, we looked at the basic syntax for creating or evaluating a machine learning model and predicting values of the machine learning model, be it a regression model or a time series or a recommendation engine. Let's look at a quick example of creating a simple machine learning model which predicts the likelihood of a mortgage borrower refinancing the mortgage. Okay, so the objective here, again, as I said, is to identify the refinance propensity of the mortgage. All right. So the way we go about it is you start with a command which says create or replace model. Then you give it a name. So in this case, the dataset name is my dataset, period. And then I've given the name of the model, refinance model. All right. So that's my initial two statements which create a specific model, or at least create a placeholder for that. Then I'm specifying various options. So I'm essentially telling BigQuery what type of model it is. So I'm telling BigQuery it's a logistic regression model that I want to create. And then I'm also telling BigQuery what is the name of the input label column, right? So the label column is, in this case, a refi underscore flag is the name of the column that I'm trying to predict. All right. So this is my options, right? And then third section I specify here saying as, and then this whole section is where I am providing the model the data that it needs to create this model. So I have a table called loan details, for example, loan underscore details. I am telling BigQuery to select certain features like interest rate, loan type, loan age, credit score. I can also specify basic transformations like extracting the year from origination date. So in this case, I'm calling it as an origination year, loan to value ratio, the housing price, the refinance flag, which is my input label column here, right? And I'm also giving it a criteria where the loan status is active. So this is my basic model, 3 sections: declaring the name of the model, declaring the parameters of the model, what is the type of the model, what variable you are trying to predict, and there are many more. We'll come to that later. This is just a simplistic example. And then finally specifying the type of the data, all the different data points that I want added as part of the model, based on which the refinance propensity will get predicted. So in this section, we are going to take a deeper dive into the model creation function for BigQuery machine learning. We have already looked at what the syntax of the model creation looks like, right? Create model, dataset.model name, transform, options, and then finally a query statement. We look at more detail. What does it do in the backend when you give a command like this? We saw an example in the previous slide, and we will try to relate back to that example also. So the first part, create model, dataset name, is pretty clear. Let's look at what happens under the hood of the transform function when you specify that while creating a model. So there are two types of transformations that we need to talk about. The first is a set of implicit transformation, which you do not need to specify. BigQuery does it on its own on the back end. All right. And these are some of the standard transformations that you would always do. Let's take a look at them. The first one is standardizing the numeric variables. It does this for all the models except XGBoost, as in XGBoost standardization of the numeric variables is not a prerequisite, but apart from that, in all models it does this standardization by default. And as you would know, standardization essentially means using the mean and the standard deviation, subtracting mean from all values and then dividing it by the standard deviation, right? The second part is the one-hot encoding, right? Again, very standard transformation for all categorical variables. And just to recap, one-hot encoding is a process whereby you convert a categorical variable like gender, for example, into numeric variables. So in this example, if your categorical variable is gender with two values, male and female, you can convert this into numeric variables for it to be fed into your machine learning models. So this will have two numeric variables, gender male and gender female, and where the value is male, it will be assigned a value of 1 else 0, and here gender female will be assigned a value of 0 in the first case, whereas male, and 1 in the second case. This is just a quick example of how the one-hot encoding would work. Most of you would be familiar, but this is just in case you're not. Similarly, like one-hot encoding, there is also multi-hot encoding for array variables which are stored in BigQuery, and we'll come to that later. Don't worry about it right now. And finally, another critical task when you are developing machine learning models is to impute missing values, right? So if the data has too many missing values, then it will render it useless for deriving meaningful insights, and hence a lot of times you do need to impute missing values. So what BigQuery does for numeric variables, it does a mean value imputation, right? So it replaces the missing values by the mean of that variable or that feature. And then for categorical variables where the values are missing, it will put them in a new category, let's say other, for the sake of simplicity. All right, so these are the set of implicit transformations that BigQuery machine learning does by itself. Then there is a set of explicit transformations, which are the set of transformations that you can specify within this transform function. All right, so let's take a look at a few examples of such explicit transformations. The first one is feature cross. So for example, there are two features, let's say gender and age, and you want to create a new feature which is a cross pollination between these two features, gender and age. That is where ml.featureCross can be leveraged. Another good example is another good transformation function is bucketize. So just as an example, you may have a feature called age, loan age rather, and you want to convert that into a few buckets. So rather than putting it as a continuous variable, you want to divide it into various buckets and then use those buckets as categorical variables in the model. That is where bucketize comes in play. So you can provide your own cutoffs, let's say between 0 to 25, 25 to 50, 50 to 75 likewise. Then another version of bucketize is quantize bucketize, where you, instead of providing a specific cutoffs, you can ask BigQuery to bucketize it based on the quantiles. So that is where quantize bucketize comes in play. There is another transformation function for expanding polynomials. So a lot of times you may want to fit a polynomial function, and that is where polynomial expand comes in play. Similarly, there are n-grams. So if there are text variables, you can compute n-grams for those features. You can do min-max scaling of the features that is there, as well as you can also apply the standard scaler. As we discussed, the standardization is something that happens by default, but this is given just in case you want to still do it where it doesn't happen. The third important part is the options, right? And there are a variety of options that you can specify depending on what type of model you're trying to create. So to start with, let's look at a simple set of options that you need to use when you're creating a regression or a classification model. So the first one is the model type, right? So you need to tell BigQuery what type of model is this. We saw it in the previous example when we are trying to predict the likelihood of refinance for a mortgage, that we specified a logistic regression parameter, logistic regression model type, right? So these are all the available options that are there within the model type parameter. So you have your linear regression, you have your logistic regression, you can do a k-means classifier, you can use a k-means for doing your cluster analysis. You can use TensorFlow, for any models that you would like to leverage from your TensorFlow environment. You can also do a matrix factorization for building the recommendation engine. As we mentioned previously, we also have the option to use AutoML regressor and classifier. AutoML, just to recap, is Google's tool which allows you to create machine learning model without worrying about which modeling technique to use. So it runs the data through all the different modeling techniques that are out there and gives you the best model, even tuning the hyperparameters even within those models, right? So that's AutoML. Then you can do deep neural nets, both from a classifier and regressor standpoint. And then finally the XGBoost, which is where your boosted tree classifier and regressor comes in. So these are all the different model types that are there at your disposal within BigQuery. The second is the input label columns, where you specify the name of the input label column, which is the feature that you're trying to predict. Early stop is an important parameter for you to use to specifically in areas where you'd like the model iterations to stop early to avoid overfitting. Again, those of you who are familiar with the regularization techniques, both L1 and L2, you can specify a value for the L1 and L2 regularizer here, for building your models. Then you can also specify a strategy for the model to take the learning rate. There are two strategies available: line search, and you can also specify a constant learning rate, and which is where if you select learn rate strategy is constant, then you also have to specify a learning rate. You can also specify an initial learning rate for the model, and again for for data sets with different weights for different classes, you can also specify whether the class weights need to be taken automatically as per the as per the distribution in the data, or do you need to specify them. And if you say auto class weights is equal to false, then you also need to specify an array with different class weights. Similarly, you can also create many other models like forecasting models or recommendation engines or neural networks by specifying different parameters for those models. This is just a quick overview of what different options are there. And then finally, we learned about the query statement. So you can specify a query statement which gives the data for your machine learning model. So this is kind of a detailed overview of the model creation command for BigQuery machine learning, and what kind of transformation options do you have at your disposal, both implicit and explicit, and what kind of modeling techniques you can work with. In the next section, we will look at model evaluation in more detail. Thank you. Next, let's look at evaluating a machine learning model that you have created with BigQuery ML. To recap, we saw that you need to use ml.evaluate function to evaluate a model that you have already created. You need to specify the model that you need to evaluate with the proper name, expanded name, dataset name, and model name. And then also you need to specify a query statement, the query statement that contains the data exactly in the same shape and form that you used in the model creation statement, including the names of the features have to be the same. What ml.evaluate does is it returns a BigQuery table, and hence you need to do select star from so that you get all the values. Now, what are the values that this ml.evaluate function returns? Let's look at that in more detail. So we'll start with the linear regression and explicit matrix factorization. These two models return the same metrics. Just to recap, explicit matrix factorization is a recommendation model where you have the user ratings as an explicit input along with the user and item details. So that's why it is explicit matrix factorization. For these two models, the metrics that you get are R squared, mean absolute error, MAE, mean squared error, MSE, mean squared log error, MSLE, as well as the explained variance. Okay. The second type of model is logistic regression for both binary as well as multivariate models, where you get all the known culprits, all the standard metrics, the ROC measure, precision, recall, accuracy of the model, F1 score, and finally the log loss. For k-means, which is your clustering models, you get two metrics, the mean squared distance, MSD, and the Davis-Baldwin index. Then for your implicit matrix factorization models, again to recap, implicit matrix factorization are the models for your recommendation engine where the rating is not explicitly provided by the user, but instead you are computing it by other measures like the amount of time the video was watched or the amount of time spent on the web page, etc. So for those models, what you get are the metrics like MAP, MAC, mean squared error again, the normalized discounted cumulative gain, and the average rank. And finally, the final class of models, which is the time series models. Again, to recap, time series modeling within BigQuery machine learning primarily leverages the ARIMA methodology, and the outputs that you get as part of the model evaluation statement are the non-seasonal P, D, and Q parameters. P is your autoregressive component, D is the integration component, and Q is the moving average component of the ARIMA AR, I, and MA. Then you get the drift, you get your log likelihood, you get your AIC score, the variance, as well as the seasonality, which is basically, is it a daily, weekly, monthly, yearly seasonality? That's what it generates. All right. So the purpose of this section was primarily to introduce you to the different metrics that BigQuery ML generates depending on the type of model that you create. And we will see this by way of an example as we progress further. All right. So in this section, let us look at how do you predict the values on a new set of data based on the model that you have just created. As we discussed earlier, there are separate set of functions for model prediction. Depending on the type of model that you have created, there are different types of functions. So for all your regression and classification models, you have ml.predict. For your time series models, you have ml.forecast. And for your matrix factorization models, your recommendation engine, you have ml.recommend. So three types of commands to predict the values depending on the type of model that you have created. And the specifications within each of these, as we discussed earlier, one, you specify your model name. Second, you specify your data set. This could be a table or a query statement. And keep in mind, this has to be the same query statement as you have defined when you trained the model, with the same set of features or same names given to the features. And then optionally, you can also provide a threshold. For example, you don't want to use 0.5 as a threshold, but let's say 0.7 as a threshold for your logistic regression. You can specify that here. Similarly, in your time series models, you can specify the time horizon as well as confidence interval as additional optional parameters. In matrix factorization, you do not have any such options. Quickly take a look at what these commands generate. So for your linear regression model, the ml.predict command generates the predicted value. So for example, if you have a model to predict housing price, it will generate the predicted housing price based on the data provided. For your logistic regression model, it produces two outputs, the predicted label based on the threshold that you have provided here. And if you have not provided any threshold, it will use 0.5. And then the probability to attain that predicted label. And for your k-means model, it provides the centroid ID as well as the nearest centroid distance for those data points. Coming to the time series models, for the time series models, what it does is after you input the model, it provides the forecasted timestamp, the value forecasted, standard error, the confidence level for attaining that value, as well as prediction for the lower and the upper bounds. And finally, for your recommendation engine matrix factorization models, it just gives you for a given user for a given item what is the predicted rating. So this is in brief the output that you can expect from your model prediction command ml.predict, ml.forecast, and ml.recommend. With this, we end the theory section of BQML, where we have just introduced you to all the different commands that exist for creating a new model, for evaluating the model, and for creating predictions. In the next section, we will take one example and walk through that end to end. We will take 3 examples, each for the classification, the time series forecasting, and the recommendation engine. So stay tuned.